Hello everyone. In this session we are going to look at Docker for Azure and DevOps. So we are going to look at what is Docker and how you can get started with Docker environment and how Docker can used in Azure environment and then into the DevOps environment. So my name is Udita Bandara. So we are doing training and consulting in Sri Lanka and Southeast Asia in latest trending topics. Okay, let's get started. So introduction to Docker. So Docker is a containerized environment that we can run our code, right? So before Docker there were some challenges. When you do application development, there were challenges when we going to deploy our application. So Docker is a technology that come to us that to save that problem. So let's look at one by one what is Docker. So it is an open source platform built in the Linux environment, right? So now you can use Docker in various technologies and it's built into various platforms. So various cloud ecosystems now runs on Docker. So Docker supports almost all the cloud environments, and also you can run Docker individually as well. So main advantage of Docker is it is lightweight, right? So it is a quite lightweight environment. It's based on Linux environment runtime, and we can run our code. Let's say you have a open source Node.js environment, we can run in a Docker. We have Windows, we can run in a Docker. So likewise, any framework, any technology that is supported in a Docker environment, right? So that is one of the key advantage in Docker. So because before Docker, what we had was the virtualization. So virtualization is a technology that we use to set up softwares or web development environments in our production environment, right? So let's say for example we have Windows application we set up in a virtualized environment, so we need to use Windows. So we need to have Windows operating system. On top of that we need to have framework. Then on top of that only we can have our applications. But with Docker environment we don't need OS environment, so OS is completely avoided. So we need not to use any OS layer. It's directly we can run everything in a Docker container. So we look at step by step how we can do this, right? So before going forward, so you can see the challenge. So challenge right now is we have a lot of different type of applications, right? So we have websites, databases, API endpoints. So likewise different this framework supports different runtime environments. So there's a crisscross of connecting all this is a really challenge. Nowadays it become quite challenge to connect all these together. So that's why so Docker environments comes in, right? So you can see when you want to connect static websites, front end, back end, database, queue, everything with these different platforms, it will become a lot of challenging, because let's say a small change of the code or a small change of the framework version will become a huge difference in the runtime environment. So that is the main challenge right now in traditional software development. So Docker is a solution to avoid that problem. So before Docker come into place, we look at the traditional approach. So this is if you look at the cargo transport before 1960s, we need to use several type of methods in order to transport these. Let's say we have a car, oil, piano. So in this slide you can see like different kind of items. So if you want to transport these, you can see we need to use different kind of transportation mechanisms, right? There's a lorry, there's a truck. So likewise different kind of transportation mechanism. But after 1960 what happened? So we get the container. So with the container you already know that we can ship almost anything without affecting one another. So in a container we can ship a car with oil, with piano, everything together, but they don't collide, though they don't have any effect with one another, but they can ship everything in a container. So container is that kind of a standard solution that come to solve shipping problem. So similar thing we can apply here in the IT world. So IT world also we have this kind of different kind of systems, right? So we have websites, we have databases, front end, likewise. So these things we can run now in a containerized environment. So Docker is the kind of the starting point of this, which is a Docker platform, that is an open source environment that comes in place, where we can use this to containerize and then run. So that's the container. You can see this, the traditional container name comes into the IT world with the Docker containerization. So that's where the Docker comes in, where it can solve this problem much more easily. We can run our application in a Docker environment much more efficiently. So you can see now the issue is fixed. So we get a different Docker environments that is running our application, because one Docker is running PHP, another Docker is running database, another Docker is running API. So likewise, different Dockers can be used to run these different things without affecting one another. So if you look at a Docker architecture, you can see the main thing is the Linux kernel here. So the Linux kernel is a runtime environment that we need to use to run the Docker, and here we have a Docker daemon. It's like a kind of a runtime environment again that we need to run, and Docker registry is the registry that is keep track of images, because when you have a Docker container, we can install these images. So images is like a set of frameworks that we can install into a Docker runtime. So then CLI means a command line environment. So using command line environments, we can use some commands to run this Docker. So in the practical demo, I will show how we can do this in a CLI environment, how we can create a container, then how we can use a standard image, then how you can build that, and how we can deploy it, and how you can use that in a DevOps process. So the Docker Hub is the traditional solution from the Docker environment. So Docker Hub is like one repository environment that we can download, and we can access the things. Later I will demonstrate Docker Hub. In Docker Hub we can create our own repositories as well, which is called private repos. So let's say you have like a customized environment where we have a Node.js and we have another framework together, then we can create our own customized repository, and then we can share with our application for the users, right? So the Docker image is like this image file. So that means it could be a database environment, PHP environment, Node.js environment. So those are standard images provided by those particular vendors. Some are paid, some are like premium images are there, some are standard open source images are there. Sometimes we can create our own images and we can submit to Docker Hub, then others can also use those images as well. And Docker contain is this runtime environment that we can set up locally, and also we can set up in the cloud that we can call, and we can host our application, and it will be a runtime environment. And we have different, like we can use this for production or staging, like intermediate location as well. That is comes part of the DevOps process, how you can set up these containers. So remember these things, Docker image is not like a VHD, like a virtual hard disk. So if you use a virtualization, it will be a virtual hard disk. It will be because it containing Windows or Linux operating system and then a file system likewise. But here there's nothing like that. There's no operating system layer here. It's only a software frameworks and the runtime. That is a custom created runtime developed by Docker. It's a separate organization. So that those those are the people that developed this initially. Now we have different variations, like more advanced solutions like Kubernetes is there, but Docker is the starting point where we can work with one single image, and we can run and we can use that in our application. So here the main thing to remember is it's not a virtual hard disk or not a file system. There's no operating system involved in a Docker. It's only a runtime, and where we can install our application and we can run. So that's the main plus point. So because before Docker we need to use virtualization. The next slide also you can see because of that you can see Docker container is a unit of software delivery. So we can run anywhere, we can run anything. So that is the beauty of it. Let's say you want to run some kind of open source framework or plugin, then you need to use Linux, right? That is the standard version. So if you use virtualization, you need to use Linux, and then you need to install the framework and you need to run it. But right now you don't need any of that. You can use the Docker container and you can set up the frameworks, that means the particular image, and then you can run. So that is the beauty of it. So where we can have multiple containers in our application based on the requirement, right? So you can run anywhere, you can run anything using that. But with virtualization, it will be a really challenging, because you need to have a OS layer, right? You need to have a OS layer with multiple operating systems. So you can build Docker images and hold that to your application. You can create the container with those images, and then you can share via Docker Hub or via Azure portal. So you can see the main difference between a virtual machine versus container. So in the left side, you can see a virtual machine. So in the virtual machine, as I mentioned earlier, you have this hypervisor and a host operating system. So the hypervisor, in that you can see there's a guest operating system is there. So here we need to, sometimes if it is like Windows or Mac, there's a licensing also involved when you get this guest operating system. Then we have the frameworks and the application. Let's say a scenario like Windows, you know, if you have a Windows let's say 10 or 8 application, then if you want to target Windows XP, then it's a different operating system. Then you need to have a separate update, you need to have a separate framework, everything just to target that particular machine. But here you don't have any operating system, you have directly Docker engine, bins and library, and you can have multiple applications running in the Docker engine environment. So that is the beauty of it. So the complete OS layer is removed and is purely run with the Docker engine. It's a Linux based, but still we can run in Windows non-Linux environments as well. In Windows, Mac, any platform, we can run a Docker engine without any issues. So here you can see how the app is running. So as I mentioned earlier, we have the hypervisor in the virtualization environment. We have a guest operating systems, so it could be multiple operating systems. So for example, let's say Windows, Linux, Mac. Then we have the library and the application. But with the Docker engine, you can see there's no guest operating system involved. It's directly all our apps with the particular library. So the libraries also, we don't need to like install or download like that. There's an image file, so we can directly get this image file and copy with our application, and we can run in a Docker environment. Okay, so this is the Docker container lifecycle. This is the entire lifecycle, not the application side of things. This is a container side of things, because when you come to application, it's a different set of steps. But this is the Docker container lifecycle. That is the entire steps for Docker. So it's based on this CLI command line interface. So main thing is the build. So you need to build the image from a Docker file or from a repository. So Docker file is like a configuration file. So you know every kind of technology going to have a main kind of a configuration file. So Docker file is this configuration file. Then run will start the container. Then we can use commit. Run to start a new image, then kill will sleep, and start will be again restart that, remove rm will be delete, and rmi will be continually delete that. So this is the Docker file. You can see Docker file is really important because you need to know the syntax of a Docker file if you want to do a more advanced set of deployment in the file. Without Docker file also small standard things we can practice, but Docker understanding Docker file is really important. It's the entire configuration file with all the config, that what kind of image you are getting, where you are going to distribute it, where you are going to deploy it, either Docker Hub or the Azure portal. Okay, so these are some of the commands you can see here. We have a standard set of commands: attach, build, commit, image, then load, rm, remove, push, pull. So likewise there are standard commands are involved when you are working with Docker. So it's really important to understand these CLI commands when you are working with Docker containers. So we are working with these commands are really important, and if it is like automated environment like Azure DevOps, then we need to set up these commands in advance in order to write everything together, right? So it's really important to understand Docker separately from other technologies. What are the relevant steps that is associated with the Docker commands? So here you can see the normal CI lifecycle. So here we have compile, test, build. Then we can push to Docker Hub, and then we can get from the host run container. So this can be a Azure container as well. or we can use Docker Hub as well. So Docker Hub is the official location, which is called hub.docker.com. so you can go to the URL, which is showing the official Docker repository, so that containing official set of repositories. So if you go to explore here, you can see the official set of repositories. So this number of images are available, so you can download all of this. So there are verified premium kind of images, certified ones like Oracle, Java, SE8, Postgre, Mongo, Ubuntu, Node.js, MariaDB. So likewise there are many, so you can see the total number here. So it's really big number. So these are the images that is available, and also you can create your own repositories as well, right? So here you can create your own repositories into Docker Hub. You can make it private or public, maybe others to use it, or you can use in your organization, your company. So let's say if you want to run Node.js environment in your Docker, so you just use this docker pull node command, right? Then you can get the this environment, right? So you can see this is the environment, and this is the official page for this one. So there are other like tutorials and to do sites that there you can see how to apply this in different stages. But using this docker pull node will be getting the Docker image into your container, and you get a runtime, and your application can be distributed into this, and you can run that in a containerized environment. Okay, so in order to download Docker, these are the requirements. So let's start with Windows. So Windows, you need to have Windows 10 Pro, Enterprise or Education, or Windows 10 Home. The Hyper-V is need to be enabled in order to do that. So these are the features. So the Windows 10 is the must at the moment. So you can use this URL to go to the official site. This is the official site where we can download from the Docker Hub, and we can get the Windows one. Similarly, you can get the Mac version and Linux version from this URL as well. So Windows 10 is a key important here, and the Hyper-V you need to have, and these are some of the configurations you need to have in order to run this software. So with this software you get the desktop localized version, and that is really helpful to communicate with the cloud environment. Okay, so now we'll move to Azure. So in the Azure, with the Docker, in order to work, we have this service called Azure Container Registry. So it's a private Docker registry based on the open source Docker 2.0. So it's a private Docker container registry where we can easily manage our application in the Docker centralized way. So the cloud solution from Microsoft Azure is the Azure Container Registry. So it's purely Docker compatible Docker Registry 2.0. So in the next step, we look at how we can create a Azure ACR, right? So you can go to the Azure portal, right? So you can go to the Azure portal like this. So in the Azure portal, what you can do is you can create a new, right? You can create a new Azure Container Registry. So you can see there's an entire section on containers, right? So where we have much larger things like Kubernetes service. So here we create this container registry, right? So here is like creating any other service. You can just select the service container registry, and you can create a new resource group, and you can give a name, right? And you can set up a server location, right? And you can give the standard premium like pricing, what are the pricing you need, and make sure the last is ending with azurecr.io. so it's the registry name, that's is the standard way. Then we can go for networking. So in this model it's by default public enable, but if you change the pricing to premium, you get much more advanced features as well. So once you do that, you can go for create, right? You can go for create, and you can create this, right? So this will be creating a brand new container registry in the Azure portal. So here you can see you will get the entire new Azure portal in your environment like this, and we are going to use this the next step in the demo, right? So once it's deployed, what you can see is you can use this in our application, right? So here we can go to this resource like this, right? So lk demo like this. So here you can see we are getting around 100 GB in this version, and 0 right now. So this is our login server lk demo like this, and the creation date. And here once it's created, you can check those in the repositories, right? So you can use that into repositories, the demo image that we're going to create. So right now we have this lk demo container registry, right? So we look at how you can use this and how we can create a image using a Docker commands, and how we can push that into this container registry, right? So I will log into my virtual remote desktop. Here this is my remote desktop environment, right? So in that I will log into the command line. So this process much easier in the command line. So make sure in order to work with this, you need to download Azure CLI command line, right? Azure CLI command line into the Windows environment, right? So once you do that, what you can do is you can log in first to make sure whether you have login to Azure. So you can use AZ login. You can check whether you have login into the Azure, right? So you can make sure whether you have login into the Azure like this, right? So when the login is successful, we will get the confirmation, right, like this, right? So now I have connected to Azure portal, right? I have connected to the Azure portal here. So now I can use AC, right? ACR login, right? Like this. So I can now log into my container instance. So Azure container instance, I can log in like this, right? Login name, right? Name is lk demo, right? So I can log into my container Azure ACR container instance, right? So like this. So the login succeeded. So now what you can do is, so you can see Docker is installed in my machine like this. So Docker is there. So now I can get a sample Docker container image. So I use Docker pull. So pull command, by the name you can see is getting. So we are getting hello world application like this. So Docker pull, you can see we are getting the latest hello world application. Okay, so once you get that, now we can version that, right? So it's because version control is really important. We can version this with the correct version. So for that we can use this command Docker. So we can use like this Docker, right? There's a command called tag, right? So there's a command called tag. Then we can give the name of the application, hello world, right? Then we need to give the ACR server, right? We need to give the server location. So what is our server location? So our server location is this lkdemo.azurecr.io, right? lkdemo.azurecr.io. So that is our server location. So I will give that, right? So that is our server location, right? lkdemo.azurecr.io. That is my server location for that container instance. Then that is not enough. Then we need to tag this using a version control name, right? Like this, right? So we can give a tag like this, right? So this is tagged using hello world, and I will give given the acr.io the location, and then hello world version 1. Then after that I can use the command docker.push, right? So I just update that. I can use the command docker.push, right? So docker.push command will be pushing this one. So we can use docker.push like this, docker.push. Then I can give the so I will remove this one, hello world, right? Then is the server and the hello world v1, right? So this will be pushing that into the, you can see now this will be pushing into the Azure environment, right? So it is pushed, right? So how to check whether it's pushed into that environment? So you can check with the Azure portal, right? So I will go back to the Azure portal like this, right? So in the Azure portal I will go back to this one I created LK. In that you can go to now repositories, right? Repositories like this. Then you can see now hello world is there, right? So you can see now hello world is there. Then in here you can see I can click on v1 like this. Then you can see around 7:45 p.m. This was submitted, and I can call this using docker pull command, right? Docker pull, I can call this. So versioning is important because here we can have multiple versions like this. So you can see using docker pull command we can call this. So that is the easiest process. You can see we can communicate directly with the Azure portal. That is the one we use the hello world, and we can directly communicate, and we can then push here. So its platform is Windows AMD platform. That's a runtime platform it use, right? So it's a small image here, so I don't think still go that much into storage. That's why still you can see the 100 GB like this. So if you go back to here, so we can use like push the pull command. So pull will be getting the image back. So right now there's no change because the push and pull happen at the same time. There's no code change or anything. So it's there's no difference between push and pull. So you can see image is up to date. And if you want to check what are the images are there, so you can use docker.images. Right, so this will show a list of images that is there. So you can see the image that I created, lkdemo.azure.io hello world is there. Just now I have submitted to the environment. So like that we can submit our application into that. So if you want to delete, you can use the delete command, and using delete command we can delete, right? So this is the standard way of communicating with the Azure Container Instance, because the portal doesn't support, in the command line doesn't support the Docker daemon, because in this application you can see Docker is need to be running. So you can see Docker desktop is running here. So Docker need to run in order to verify this. So Docker in order to run, then you can connect with the Azure. So if I go to this step again, first I use ac.login to log into the Azure portal, right? After that I use Azure ACR login name lkdemo. So that is the name of the Azure Container Instance, and I login to that instance. Login succeeded. Then docker.pull hello world. So I pull the hello world where the hello world application is pulled, right? Then I use the docker tag hello world lkdemo into hello world v1. There I tag the version 1, right? v1 is tagged based on this. Then after that I use docker push, and I use the server name and the v1, and based on that is pushed to the server, right? Then if there's any code change, you can use the pull again, then it will be different, but at this stage there's no difference, so it will be the same thing. Then I can use docker images, where I can see what are the images are there. So here you can see lkdemo.azurecr.io hello world image is there locally, and also if you go to the cloud environment in the demo, you can see here where if you go to repositories, you can see I have these repositories. So similarly I can create a simple so let's say if you are working with the same project, I can here I gave the v1, so similarly you can give v2 for the version 2 update, v3 for version 3 update. So likewise is under the hello world, but here you can also create multiple repositories as well. So in here we discuss about one repository, in that we can have multiple versions, right? Multiple versions running inside. So likewise we can create the Azure Container Instance here, and in the repositories it represents the Docker images, right? So now we look at how we can facilitate this in the DevOps environment. Okay, so here you can see I have used Azure ACR, and in that I use and this is the earlier version, the demo I have prepared, hello world. So I have submitted that into the Azure Container Registry, and you can see the manifest and the image running here, right? Okay. Then if you go to Azure DevOps, so in the Azure DevOps environment, the steps are a bit different because we need to use this in a different format. So I will go to the Azure DevOps project and I will explain from there. Because in the Azure DevOps environment, the steps are a bit different because Azure DevOps is the complete end-to-end platform where we manage our project from start to end. So this Docker setup comes in only one specific location, right? So I will show this project. So in this project I have a web application, right? So here in the repos you can see I have a web application like this. So now this web application I can deploy into in a container, right? So in the container I can run this. So earlier I used the Hello World application, but now I have this web application that my developers developing in the repos environment, right? Now I can go to pipeline. So here you can see Azure pipeline. So in the Azure pipeline, as a runtime medium, I can set up Docker. So there are multiple runtimes that we can have. One is Docker, other is Kubernetes environment. So in this case I'll be using Docker. So you can see here is a kind of a different language where we have a YAML file. So here you can see YAML is a YAML file, is a configuration file for Azure pipeline. So here we can see we have the standard YAML configuration. So at the end we have these settings. So here we can see Docker task 1 where we can set up, we can build, tag, push Docker image to run a Docker command. So what is the important? So where we can keep track of that and we can use the Docker container to run our application. So if there's any changes, it directly push into the Docker container as a latest update and it will be distributed to the customers, right? So without worrying about the deployment. So we can make it as automated deployment. So it will running hosting in the Docker container environment and we can use that, right? So here we can see we first build an image, right? So there are mainly two tasks when it comes to Azure DevOps pipeline. There are two tasks. One task is build an image. So here when you build the image, again you need to give the container registry, right? So here you can see this is my container registry here. Then I need to give the configuration of the Docker file Docker file containing the configuration where I can set up all the configuration information. Then I can give like that earlier the version number, right, and the image name. Then once you build the image, push the image part. So when the new development comes in, if you want the automated process, we can, or it will automatically build the image and push the image into the server. It will get the latest update automatically. But if you want to put some permission, you can set up some permissions also, where some permission based on the approval we can set up that, right? So that is the process in the build pipeline, right? So in the release pipeline we have this, right? So as a release, right, where we can set up the release. So it is based on that Docker created. So you can see where the Docker is connected in the DevOps process, right? Where the Docker is going to connect in the DevOps process, right? So here we have the as I mentioned earlier, right? So here you can see I will show the release pipeline also. So we are having Azure CLI, right? So this is a CLI command, right, like this to configure. Then we have the deployment. So in the deployment I will deploy to here. So here we have the ACR login server and Docker push. So at the end you can see it used for building and also the finally releasing I use the Docker push command. So just like I use in the command line, I use the Docker push and it will be updated to the latest version. So in this case, if you want, you can put some permission, because otherwise when some developer makes some mistake also, that mistake automatically pushed into the final version and that will be displayed in the application. So you can set some permissions to like approve. Then once approved, you can go for push, and in the push command you can do that. So you can see Docker makes the life much easier, where it connected directly using our container. So you can select here what is the container you need. So you can use a Linux container or Windows container. Since this is a open source .NET, that means .NET Core application, we can run in the Linux container. Then we can give the login server, right? So variables are here. So you can see login server, right, like this, password, username, then the resource group. So like that, these configurations are there. Then we can set up via the app service, we can deploy, and the command is docker push, and push will be pushing the application back to the the actual deployment target, right? So here we are using Azure App Service as well, because it includes web deployment as well. But you can see where are the connecting dots happening in the Docker, right? So where are the Docker going to connect, or the Docker is connecting in the entire DevOps process, because DevOps is end-to-end. The process is a really big process, but here I want to highlight where the Docker is going to plug in into relevant steps, right? So Docker have some limitations. In this session we are only discussing Docker, but Docker overall have some limitations when it comes to much larger scale applications. That's where the Kubernetes comes in. Azure Kubernetes Service is a solution for larger hyperscale applications, but here we discuss only standardized applications. So in that case, Docker is a really suitable kind of a candidate. So here we can use Docker in this case without any issues. So you can see where Docker comes in the build pipeline and the release pipeline, right? So similar thing we can verify and see when you go to the Azure portal. Also you can see that container registry, right? So in that registry you can see, if you go to repositories, you can see in the repositories the similar thing is there, web, and is use the web, right? So here you can see like this, it is there, right? So it is there like this. So it's running a .NET Core application, right? It's running a .NET Core application, and it's running in the Linux environment, right? So in this case, using Docker file and YAML, we can customize this script. So we don't need to write the script like I wrote in the DOS environment. I can like put the script, the commands in a script, and it automatically is running as automated overall end-to-end process. So that is the advantage of that, right? So you can use the dev.azure portal. So here I have this project. So in that I use Docker into the pipeline. So the project we have created, right, I can use in the build pipeline and also in the release pipeline. So in the build pipeline, I have set up in a YAML file. So it's a YAML configuration, right? So in the YAML configuration, I have two steps. One is here build the image, right, based on the Docker file. Then lastly push the image, right? So those are the steps I want to highlight. So here you can see in the repo, you can see the standard Docker file. So this is the repository that we are getting the ASP.NET Core expose 80 443, and this is the other .NET Core version working directly. Copy code from and publish code as a final code. So there are different steps are there when it comes to Docker file configuration compared to Docker commands, right? Because Docker file is a configuration of that image, right? That image containing in the container. So there's a copy command, publish command, final command likewise, and we need to look at the compatibility of the versions of software we are running. So you can easily look at those, and you can see based on the configuration. So it will be saved under this project. You can see this is the project file. Docker file is saved under location. Then when you go to pipeline, build pipeline, you can see that Docker file is located in that particular repo, will be highlighted and as /Docker file like this. So in the DevOps environment, once you set up this, is much more easy, because this is only you need to set up at once, right? It's not like every time. Once you set up this, is automatically when developer comes in and adding a new feature, it will be going into the build. So it will getting the build and push it as the latest version, and then it use that and deploy as the latest version. So it's an automated process. So we only need to do this once, but if there's issues comes in, we need to maintain and we need to fix that while this process is going in the development and deployment lifecycle. So you can see now, I think you get the idea about this DevOps Azure pipeline YAML. So here you can see this Docker build and push command, and here's a creator image. So this YAML also a different programming language. it's really important to understand this scripting language, because using this scripting language where we can script DevOps processes, and we can use that in the DevOps lifecycle, right? So in this demonstration, I have used Docker and Docker in Azure using Azure Container Registry, and Azure DevOps using Azure DevOps environment. And you can see the places that Docker is connecting in a cloud environment in the Azure portal, right? So you have seen how the Docker is placing in the cloud environment using a container registry, and how the Docker is placing in the DevOps environment in the build pipeline and into the release pipeline, right? So that is the end-to-end goal of this session that I want to highlight, where to get an idea about Docker, what is Docker and what are the steps to get started with Docker, then how the Docker can be used in the Azure environment, and how the Docker can be used in the DevOps environment. So that is the main goals that I want to highlight in this meetup session, right? So if you have any questions, you can email to my email address, right? So thank you for attending this meetup, and hope to see you soon again. Thank you.